No, it's a microwave transmitter. Well, microwaves are just electromagnetic waves, right? In the tens of centimeters. Um, X and Y are placed 12 centimeters apart, right? And connected to the same source. Okay, so if they're connected to the same source, this means that they're going to be the same wavelength, right? And they're going to be in phase. More or less, right? Okay, but anyway, there they are. Assuming these wires are the same length, right? Okay, a single receiver is placed 54 centimeters away and moves along a line AB that is parallel to the line joining X and Y. Okay, so there we go. Okay, maxima and minima of intensity are detected. So this is like when in the classroom when we walked around, we plugged one ear and I had the two speakers playing. And ultimately what's going to happen is you have two different path lengths, right? You've got this path length and this path length, right? And when that difference in distance is, and I'm using equation 4.4.4, right? That just says that if the difference in distance is 1/2 a wavelength, then you get destructive interference, and when the difference is a whole wavelength, you get constructive interference, right? So the formation of intensity minima is because the path length is different, right? And one path length is a 1/2 a wavelength longer than the other one. And of course, what happens then is that you receive a trough from one at the same time you reach a crest from the other. So you get destructive interference. That's what you need to explain. And there's two things you need to say. So figure that out, right? And then it says the distance between the central maximum and the first minimum is 7.2 centimeters. Okay, calculate the wavelength of the microwaves. Well, okay, so the way we did this last year was kind of like this. So here's X and here's Y, and this is 12 centimeters, right? So it's 0.06 and 0.06 to the center, right? And then we've got 54 centimeters there, and then we've got this line here, like that, right? And they say that this is of course a maximum because it's the same distance from X and Y, and so therefore it's receiving the crests at the same time and the troughs at the same time. Okay, and then they say that if we go 7.2, that we get a minimum. Okay, so what we're going to do is we're going to figure out this distance. I'm going to call this R, right? I'm going to figure out this distance here. It's so hard to draw a straight line. And that distance there, right? So figure out what YR is, right? Figure out what XR is, right? That point is R, so XR is this line there, right? So for example, if this is 0.072 meters, right? For this distance, it's going to be, let's draw a picture of it. XR is over 0.54, and then if this is 6 centimeters and that's 7.2 centimeters, this little distance here is 1.2 centimeters, right? So if you can imagine this distance, I'm not going to try to draw that straight line, right? But it's going to be the square root of 0.54 squared plus, and then this little distance here, that's 0.06. This is 0.072, so it would be 0.012 squared, right? That would be XR. I'll let you figure out what YR is, okay? And then, so find XR, right? Okay, and then XR minus YR, or vice versa, right? Absolute value of that, right? That's going to be, if it's a minimum, that's going to be a 1/2 a wavelength. So when you find that difference, multiply by 2, right? And then that'll give you the wavelength, okay? Now, we're of course doing it the hard way, but that's the actual fact. This is a factual way. There is an approximate way to do this. If you look at formula 442 says that the S is equal to lambda D over D. And it's like, well, what the heck are these things, right? At the end of the day, I might forget what these are, okay? And what it is that if we look at the Let's try red here. Okay, this is d. This is little d here. Okay, and the wavelength is the wavelength of the light, right? Okay, so what we can do is we can say small is to big, lambda is to d, as small is to big, and small would be this s, and then this would be d here. Are you going to remember all that? I don't know. I mean, basically there's a proportion. So the wavelength is to the distance between the sources, as the little separation on the screen is to the big distance from there, right? Okay. So ultimately the wavelength would be S d over big D, right? Which this is going to be what, 0.12. And then understand that this distance is not the distance separating the maximum from the minimum. It's this distance separating the maximum to the next maximum. Okay, so this would actually be 2 times 0.072. Right? Whoops, sorry. I messed that up. This is 2 times 0.072. This would be 0.12. This would be 0.54. So you could do that. You know, the question is, are you going to remember that? I don't know. We didn't really use it, and it's kind of approximate. So this is a case where you actually get a bit of a different number if you do the exact way. Anyway, happy hunting.